Okay, good evening, friends. Today we discuss about the introduction of thermodynamics. Okay, this is our course outcome. We have 5 units. Each unit having one course outcome. The first course outcome is related to first law of thermodynamics, and second outcome is related to second law of thermodynamics, and the third course outcome is related to ideal and real gases, the properties. Okay, then fourth outcome is related to properties of steam. Okay, then the fifth outcome is related to properties of air, which is nothing but psychrometric process. Okay, the first and second units are already in, and also you studied in your schools and first year also. Okay, then the third CO is related to gas properties. Okay, then the fourth CO is properties of steam, which is nothing but properties of pure substances. The pure substances means any mixture having same homogeneous mixture. Okay, if for example water and steam both are water, but phase is a difference. One is liquid phase, another one is a gaseous phase. But the chemical composition of the both that is H2O. Therefore, the mixture is called homogeneous mixture. Okay, if anyone having homogeneous mixture, that mixture is called pure substance. Okay, for a heterogeneous mixture like water and air is not a pure substance. The pure substance means same molecules with different phase conditions. Okay, then the fourth unit related to psychrometric process, which is nothing but air conditioning process. Okay, the principle is used in AC and fridge, etc. Okay, these are the course outcomes. Then the next slide is about question pattern for our subject. In that question we have 3 segments: part A, part B, part C. The part A having 2 marks, which is equal to 20 marks, and part B having 4 marks, which is equal to 20 marks, and part C having 5 marks, which is equal to 60 marks. Therefore, in that question pattern, the large answered question or there are descriptive questions, the weightage of descriptive questions is nearly 50%. Therefore, it is not enough to pass the examination. Okay, therefore you have to concentrate at 4 mark and 2 mark also. Okay, then now we go to the subject. Okay, thermodynamics can be defined as the science of energy. Although every body has a feeling of what energy is, it is difficult to give a precise definition for it. Energy can be viewed as a ability to cause changes. The name thermodynamics stems from the Greek word therm, which is the meaning is heat, and dynamics, the meaning is power, which is most descriptive of early efforts to convert heat into power. Today, the same name is broadly interpreted to include all aspects of energy and energy transformations, including power generation, refrigeration, and relationship among the properties of matter. The power generation means the power plants, and refrigeration means our household refrigerator. Okay, then conservation of energy. It's one of the most fundamental laws of a nature is nature. It simply states that during an interaction, energy can change from one form to another, but the total amount of energy remains constant. That is, energy cannot be created or destroyed. For example, a rock falling a cliff picks up speed as a result of its potential energy being converted to kinetic energy. Okay, the conservation of energy principle also form a backbone of diet industry. A person who has a greater energy input, that means food, that energy output, which is exercise, will gain weight It is stored energy in the form of fat, and a person who has a smaller energy input than output will lose weight. The change in energy content of a body or any other system is equal to difference between the energy input and the energy output, and the energy balance expressed as delta E, which is equal to E in minus E out. Okay, here the two examples I explained. One is the rock cliffing from rock. The rock is dropped down from the hill, and another one is the weight loss and energy loss or energy storage in the form of fat in a human body. These two examples are I said. Okay, these are the examples for energy conservation. Okay, in the first example, the potential energy is converted continuously kinetic energy. Okay, therefore the energy, one form of energy is converted to another form of energy. Here there is no energy destroyed or created. Okay, then those are the application areas of thermodynamics in solar areas and household refrigerator and ships plates and cars, power plants and medical purposes and profit processing industries. Those are the application areas of thermodynamics, and mostly probably all areas having thermodynamic principles. Okay, then thermodynamic system. Before that, I said some examples. I said some introduction. The first law of thermodynamics is simply an expression of conservation of energy principle, and it asserts the energy is a thermodynamic property. The second law of thermodynamics asserts the energy as a quality as well as quantity, and the actual process occurs in direction of decreasing quality of energy. For example, a cup of hot coffee left on a table eventually cools, but a cup of cold coffee in the same room never gets hot by itself. The high temperature energy of coffee is degraded once it is transferred to the surrounding air. Although the principle of thermodynamics have been in existence since the creation of universe, thermodynamics did not emerge as a science until the construction of the first successful atmospheric steam engine in England by Thomas Savery. Okay, then we go to the thermodynamic system. A system is defined as a quantity of matter or region in space chosen for the study. The mass or region outside the system is called surroundings. The real or imaginary surface that separates the system from its surrounding is called boundary. Okay, they clearly shows the figure system, boundary, and surroundings. Okay, then the boundary of a system can be fixed or movable. Note that boundary is contact surface shared by both the system and the surroundings. Mathematically speaking, the boundary has zero thickness and thus it can neither contain any mass nor occupy any volume in the space. Okay. For real-time example, if you consider a book, that book is a system, and except that book is except the book, yes, others are surroundings. The outer border of the book is boundary. Okay, that then the book is imaginary, then the boundary is imaginary one. Okay, the boundary may fixed or movable. In most of the time the boundary is fixed, and in some cases the boundary is movable. For example, syringe. In the syringe we have one cylinder and another side on piston. Therefore you consider as a cylinder, the in between space as of space of the cylinder and the piston, we have one space. That space, if you consider that base face as a system, therefore then the boundary is moved. Okay, then system may be considered as a open, may be considered as to be closed or open, depending on whether yes is fixed mass or fixed volume in the space chosen for study. A closed system, another name is control mass. That word shows the meaning control mass, which is means mass is controlled by a particular definite area. Okay, but the system is called closed system. Consists of this it consists of a fixed amount of mass, and no mass can cross its boundary. That is, no mass can enter or leave a closed system. But energy in the form of heat or work can cross the boundary, and the volume of closed system does not have to be fixed. If a special case even energy is not allowed to cross the boundary, that system is called isolated. Okay, in closed system energy interaction is there but mass interaction is nil. That means in the closed system there is no mass entering or leaving the system. In open system, but at the same the energy interaction also nil, the system is called isolated system. And another type is open system. Open system is mass interaction also there and also energy interaction also there. Okay, here open system, we have to heat the water in a open pan. Here the some amount of heat is transferred from stove to pan and pan to water, and also due to the heating of water some steam is produced and escape to the atmosphere from the pan. Therefore here energy interaction also there in the form of heat from stove to water, and mass interaction also there from pan to atmosphere. Okay, in terms of steam. This is the example for open system. Okay, our human body, our breathing process is also a open system concept. Here we inhale the air and some combustion takes place, then CO2 is produced, and the CO2 is we inhale the CO2. Okay, here the mass interaction, some amount of mass in and some amount of mass out. This is a mass interaction. And inlet air is very cold one and exhaust air is sense very hot one. Therefore energy interaction also there. Therefore our human breathing process, our lungs, if you consider lungs as a system, then the lungs is a open system. Here energy interaction and also mass interaction is there. Okay, if you are isolated, when we are isolated, if you means isolated, our body is completely dead. Okay, then closed system. Okay, if in the world no systems as a closed system. Okay, in all the system as a open system. Okay, closed system is a imaginary one. Okay, in any process some mass interaction is there. Consider, if you consider as a tire, cycle tire or bike tire as a closed system, the the gas air content in the tire is not escape from the atmosphere, but in long time the air pressure is continuously decreasing. Then what is the reason behind that? Okay, then at an extent we have to fix the system as a closed system, but completely we cannot fix the system as a closed system. Okay, in all systems as a open system. Imaginary system is one, closed system is a imaginable one. Okay, but we have to fix certain time the system as a closed system. Okay, therefore here I set on an example. There's water heating in a closed pan. Yes, the steam not escaped from this pan due to the top weight of the cap. Okay, but certain time the pressure is increased. Therefore, then the pressure due to the increase of pressure, the top pan is slightly upwards. Then the steam is escape to the atmosphere. Then so that the particular instant we have to fix. We can fix the system as a closed system. Then before after that it changes to the open system. Okay. Then was theoretical example for the closed system is pressure cooker, hot water, hot flask. Those are the closed system examples. Okay. Here there is no mass interaction, but energy interaction is there. Then isolated system. There is no mass and there is no energy interaction is that the system is called isolated system. Okay. This is also a imaginary one. In the world, there is no system as an isolated system. Okay. If any one transfer is there, any of the one transfer is occurring between the system and surroundings. It may be energy or it may be mass. Therefore, there is no exist in isolated system. But certain assumptions we have tell the system as system can as a isolated system. Okay, and in other words, system plus some surroundings compounding, a compounding of system and surroundings you can consider as a isolated system. Okay, isolated system having system and also surroundings, cumulative one. This is considered as a isolated. Consider as a isolated system. Okay, then open. Then I missed one thing. The open system is also called control volume. It means in open system we have to control only the mass of the system. Okay, we cannot control the volume of the system. We cannot control the mass flow and energy flow. Okay, this is how the open system is called in another way, that is control volume system. Okay, these are the systems, classification of system and examples of systems. Okay, this is the comparison of open, closed and isolated system. And thank you.